To use L'Hopital's rule, we need indeterminate form 0 over 0 or infinity over infinity. Let's see what we have here. We have limit as x approaches 0 from right. Cosine of x is our base and exponent is 1 over x squared. Let me rewrite this. We have limit as x approaches 0 from right of cosine of x to power 1 over x squared. So now when x approaches 0 from right, cosine of x is going to 1. And when x approaches 0 from right, 1 over x going to positive infinity. If you don't see this, you can always draw the graph of function 1 over x as hyperbola. This is because we have positive numerator, it means we have this hyperbola in first and in third quadrant. And where approaches 0 from right, our graph going to infinity. So we have 1 to power infinity, because infinity squared, it still will be infinity. So we need to rewrite our function, because we have 1 to power infinity. We need 0 over 0 or infinity over infinity. So we will put f of x equals our function cosine of x to power 1 over x squared. Now I will put on both sides natural log of f of x. This is equal natural log of cosine of x to power 1 over x squared. Now we will use properties of log, and this exponent goes down. We have 1 over x squared times natural log of cosine of x. This is equal. We have 1 times, we can rewrite this, natural log of cosine of x over 1. So we have 1 times natural log of cosine of x is natural log of cosine of x over x squared. Now we will find limit as x approaches 0 from right of natural log of f of x. This is equal. We have to copy limit as x approaches 0 from right, and natural log of f of x is equal natural log of cosine of x over x squared. Let's see what will be when we substitute x's by 0. Let me put this in brackets. Natural log of cosine of 0 is 1. So we have natural log of 1. Natural log of 1 is 0. So we have 0 in numerator and x squared. So we have 0 squared is 0. So we have indeterminate form 0 over 0. So now we can use L'Hopital's rule. It means we have to copy limit as x approaches 0 from right, and we have to find derivative of function which is in numerator and derivative of function which is in denominator. We have natural log of cosine of x. We have composite function here. It means we have to use formula to find the derivative. D of natural log of u with respect to x is equal 1 over u times derivative of u with respect to x. In our case, u is equal cosine of x. Derivative of cosine of x negative sine of x. So we we'll have in numerator 1 over cosine of x times negative sine of x. And derivative of x squared is 2x. So this is equal. We have to copy limit as x approaches 0 from right. And in numerator we have positive times negative is negative. We have sine over cosine. Sine over cosine is tangent of x, and denominator is 2x. Let's see what we will have now when we substitute x's by 0. Tangent 0 is 0. 2 times 0 is 0. So we have 0 over 0. Again, we have indeterminate form. So we have to use L'Hopital's rule again. It means we have to find the derivative of numerator and derivative of denominator, and we copy limit as x approaches 0 from right. Derivative of tangent is secant square, so we have to copy negative sign. We have secant square of x over derivative of 2x is 2. So this is equal. Now we have to check what will be when we substitute x by 0. Secant, if someone forgot, secant of x is equal 1 over cosine of x. So now when we substitute x by 0, we have cosine of 0. Cosine of 0 is equal 1. So we have 1 over 1 is 1. So when x is equal 0. So we have here in numerator negative sign. We have to copy. And 1 square is still 1 over 2. So we can write that limit of our function when as x approaches 0 from right of natural log of f of x is equal negative 1/2. So now we have to come back to our function. We have to find limit as x approaches 0 from right of cosine of x to power 1 over x squared. This is equal limit as x approaches 0 from right, and I substitute this function by f of x. Let me write this. Now we have to use formula. When we have f of x, we can rewrite this that this is equal e to power natural log of f of x. I just use property of log. So this is equal limit as x approaches 0 from right. We have e to power natural log of f of x. Now we will use property of limit, and we have e to power, this limit is going to the power, so we have limit as x approaches 0 from right of natural log of f of x. This limit we just found. Limit as x approaches 0 from right of natural log of f of x is equal negative 1/2. So we have e to power negative 1/2. Negative sign means we have to take down this e. So we have e to power 1/2. 1/2, it means we have 1 over square root of e. This is my solution.